Hi everyone, my name is Manuel Espinosa and welcome to my YouTube channel. Today we are going to practice about a very important topic in statistics. That topic is about the normal distribution. And we are going to see what are the properties of the normal distribution and some applications of the normal distribution in the resolution of problems. Hola a todos, mi nombre es Manuel Espinosa y bienvenidos a mi canal de YouTube. Hoy vamos a ver un tópico que es muy importante en estadística. En él vamos a estudiar la distribución normal, vamos a ver las propiedades de la distribución normal y algunas aplicaciones en la solución de problemas.
The quantitative continuous data could have different forms: uniform, skew left, skew right, bimodal, or normal, among others. The normal distribution is single peak and symmetric and resembles an upside-down bell. Among the application of the normal distribution, we have the scores of a test, people income, stock market, heights, blood pressure, and shoe sizes. The normal distribution is also called Gaussian distribution because the name of the famous German mathematician Karl Gauss who discovered it. The shape of the distribution is determined by the mean and the standard deviation of the dataset. The measures of central tendency, mean, median, and mode have the same numerical value that divides the distribution into two equal halves. The curve is always above the x-axis and extends forever in opposite directions, getting closer to the x-axis, but never touching it. The x-axis is a horizontal asymptote. The function is always positive. The normal distribution is a density curve, means that the area under the curve and above any range of values is the proportion of all observations that fall in that range. The proportion of all the values is between 0 to 1 or between 0% to 100%. Since the mean and the standard deviation determine the shape of the normal distribution, there are three possible scenarios. Distributions have the same mean, but different standard deviations. One curve is more spread out while the other one has values more clustered to the mean. The two distributions have the same standard deviation but different means. Or both, the means and the standard deviation are different. The empirical rule determined that approximately 68% of the data is contained within one standard deviation. Within two standard deviations is contained approximately 95% of the data. And within three standard deviations roughly concentrated 99.7% of the data. This left only 0.15% on the left tail and 0.15% on the right tail. Laura scored 85 points in a test, and this score is two standard deviations above the average score. One standard deviation is 4 points from the mean score. This is the position of Laura's score. Substituting the standard deviation by 4 and solving for the mean. The average score in the test is 77 points. In a normal distribution, there is a value of 80, 2 standard deviations above the mean, and 40, 2 standard deviations below the mean. The distance between this upper and lower bound of the interval is 40 units. And there are 4 standard deviations between 40 and 80. 40 divided by 4 equals 10. 1 standard deviation equals 10. It is 10 units away from the mean. And the mean equals 60. In a normal distribution, 57 falls 1 standard deviation below the mean and 81 is 2 standard deviation above. Calculate the mean score. The distance between the upper and lower bound of this interval is 24. Since between 57 and 81, there are 3 standard deviations. One standard deviation is 24 divided by 3 or 8. The mean minus 8 is 57, then 57 plus 8 equals 65. The mean is 65. The average score of the test is 65 points. The heights of women in the U.S. are normally distributed with a mean of 64 inches and 2.75 inches standard deviation. What is the percent of women whose heights are between 64 and 69.5 inches? (69.5) is 2 standard deviations on the right of the mean. If within 2 standard deviations are 95% of the data, then the interval from 64 to 69.5 contains half of that 95%. The answer is 47.5. Approximately 48% of the women in the U.S. have a height between 64 to 69.5 inches. Battery's lifetime is normally distributed. The mean is 500 days, and the standard deviation is 61 days. Approximately what percent have lifetimes longer than 561 days? "561 days is one standard deviation to the right of the mean. We are looking for the proportion represented by the shaded area on the right side of 561 days. On the left side of the mean, there is 50% of the data. If whiting one standard deviation, there is 68%, then there is 34% from the mean to the first standard deviation of the right of the mean. The shaded area contains the difference between 184%, contains 16%, about 16% of the batteries have a lifetime longer than 561 days. A survey revealed the mean number of cans of soda consumed per person per week in a high school is 20 with a standard deviation of 3.5. Find an interval that the total number of cans per week, approximately 95% of the population of this school will drink. Within two standard deviations contains 95% of the proportion. The lower bound of the interval is 20 minus twice 3.5, and the upper bound is 20 plus 2 times 3.5. 95% of the population of this school drink between 13 to 27 cans of soda per week. The lifespan of a 60-watt light bulb is normally distributed with a mean of 1,450 hours and a standard deviation of 8.5 hours. If a light bulb of this kind is selected, what is the probability that the lifespan will be between 1440 and 1465 hours? The lower bound will be a little less than 1 standard deviation to the left and less than 2 standard deviations to the right of the mean. Using the TI-84 Plus. Type the value of the lower bound. Then the upper bound. The mean. And the standard deviation. Then, click Enter. The probability the lifespan of the light bulb is between 1440 to 1465 hours is approximately equals to 0.8415 or 84.15%.
Thank you for watching. Until the next video. Bye. Gracias por observar el video. Hasta una próxima entrega. Adiós.